Hello friends, today we are going to discuss about our ISIS routing protocol. It's the same like OSPF because both are link state routing protocol, and it maintains the link state information of each other router. And it also the classless and support FLSM and VLSM. ISIS using just algorithm. Meanwhile, this ISIS it have 10 metrics for all the interfaces, and the AD value is 115, and ISIS will using to the inside of the ISPs. Whoever using example, we have a multiple ISPs. All the ISPs they have to use some IGP protocol. It should be ISIS or else it will be in OSPF, because this is a link state protocol. It will maintain the link state information to all the nodes. So IGP protocol, ISIS most of the case it's one of the IGP protocol. It support IPX, Alcatel also. ISIS is this is an intermediate system to intermediate system that is nothing but communicate the router to router devices. And meanwhile, here the metrics we have this all the links using the metric value is a 10. That is a default one. If we want if we need some extra metric value, we can able to change manually. Here it is no bandwidth calculation like OSPF. We have to calculate some calculations like cost 10 to the power of 8 kind of formulas, but here nothing, no bandwidth calculations are happening here. The main target is here we have some levels. In ISIS we have some levels. So levels are level 1 and level 1 and level 1 and level 2 and level 1 and 2. This level 1 and level 2, it will act like a ABR router in OSPF. And level 1 it is a intra area routing routers, and L1 routers, that is a internal routers. So that means L1 router can able to communicate with in L1 routers. For I mean that L1 router, it will exchange the routing information to L1 routers only. It won't communicate with L2, but it can able to communicate with L1 and L2 routers. I mean that means ABR routers. This router will establish the neighbor only on L1 and L2 routers. That means here I have L1 router. I am going to communicate with L1, or else I can able to communicate with L1 and L2 level. So in this category, this neighbor will accept, and L1, and that other neighbor is L1 and L2 area also same, so it will be accepted. So act like OSPF internal routers, total stuff. That means this L1 routers, the LSDB only maintain the in L1 routers. It won't establish the LSDB informations to other L2 routers. Yeah. So L1 router will only establish communication in L1 routers. It won't exchange the other routing. Like if we need to communicate with L2, so we need a support from L1 and L2 routers. Then only the connection and establishment, the routing information, everything can able to access. Otherwise the neighbor won't came up, the adjacency it won't came up. And this another scenario, another level is L1 and L2. So here I have few example, area 1 and area 2 and area 3. So area 1, this L1 router I'm going to communicate with this 2 here from L1 and L1 and L2, and meanwhile should be communicated with here. So here I have two three areas, that is area 1, area 2 and area 3. So area 1 needs to communicate with area 2, and this L1 router going to communicate with area 2 L1 router. So at that time the communication, it should be go via L2 router, then it is going to the other area, that is from area 1 to area 2. In that time it should be communicated with L1 and L2, that is area border router for this area 2. Meanwhile here also we have another border, that is area 1 border router. So it is going to border router, it is going to communicate here, then traffic should be reached to L1 to L2, then finally it will reach our destinations. This is L1. So in this scenario, for example, L1 to L2, I am going to communicate with this other area L2 router. Here I have area 1 and here I have area 2. So it won't be communicate, because we need L1 and L2 router, then only the connectivity it will be communicated with L2 router. Otherwise it won't communicate with other area L2 routers. We need L1 and L2, then only it can able to communicate with others. See the diagram here. So this is a way to communicate this L1 and L2. I'm going to configure using Alcatel router. I'm going to show you how to configure the ISIS routing protocol in Alcatel router. Here I have two interfaces, three routers, and one it is 1.1, here 1.2, here 2.1, 2.2. Meanwhile I'm using loopback interfaces, that is 8.1 and 9.1. Let me show you the interface configuration and everything. So I need to log in my router. Okay. In this R1 router, that R1 to show router interfaces. I have two interfaces. One it is 1.1 and another one is system IP. And here I have three interfaces. Two, it is one is R2 to R1, another one is R2 to R3, and system interface. And then finally it is R3 router. So I have two routers, but I need to configure these two loopback interface in my router 1 and router 3. I'm going to configure that. So router interface, loopback interface name, it's a loopback, and loopback address 192.168.8.1/24 shutdown exit. Now I need to check my interfaces. Here it came loopback interface. Earlier I have only on two interface, that is R1 and the system. Now I can able to see three interfaces. The same thing I'm going to do it here, but here I'm using 9.1 network on R3 side. Configure router interface, loopback, that is the interface name, 9.1/24 here I can able to see my loopback interfaces are up, and IP system, everything, it is up now. So this is my R1 router, and here I can able to see 1.1 and 1.2. that is 1.1, this is an interface, and loopback interface is 8.1. and then R2 router, here I have two interfaces, and another one is system IP. So this is a 2.1, 1.2 and 2.1 here. And finally there is a R3 router. Here I configured a new loopback interface, that is a 9.1, and R3 to R2 interface I have, and system IP. So I'm going to configure, before I'm going to ping this node 1.1.1. right now I'm in 1.1.1 router, because right now I'm in R1 router. I'm going to ping 2.2. so I'm not able to ping because no routing protocols configured here. I'm going to configure the ISIS routing protocol. My area ID is 40. My area ID is 10, and that interfaces, I have interface system, that is one of my interfaces, and come back interface. I need to add all the interfaces, R2, then interface again, then loopback interface, exit, and info. So this is my ISIS configurations, and meanwhile in this ISIS, here I need to mention my levels. So level capability already we discussed in this session. So level, I'm going to configure, this is a level 1. So here we can able to see here level 1, level 2, and level 1 and 2. I'm going to configure, like, this is my level 1, and this router, this R1 router, it will be in level 1, and R2 it will be in level 1 and 2, and this R3, it's my level 1 router. This is my level 1, and all the interfaces I'm going to consider like a point to point interface type. It should be in point to point. So my configuration is ready now. I'm going to check my ISIS adjacency. So no adjacency because I didn't configure my neighbor side. So I need to configure the R2 router first. Here, configure router ISIS area ID. It should be same. So this is my area ID. Then I need to configure the interfaces. This is R1, and then shut down. Then again interface type, it should be P2P interface again, R2 to R3, then interface type to be row. Then here I am going to check sure router ISIS adjacency. See, one side it came up. Adjacency detail, here it is a L1. I need to configure my level capability. Here it should be capability level 1 and 2. So here I have the uptime, and the circumstances level 1. It is IP, neighbor IP is 1.1, so I can able to access this ping and everything because that is a point-to-point connection only. Here we can able to see the metrics. Let me show you those metrics information. So just see here, see the metrics. It should be 10. And I forgot to say the metric value, it will be 10, and our downtime is 30 seconds, and our metric value is 10, and our metric our hello packet will be default hello. It will be in 10 seconds, and that time is 3 times of hello, that means 30 seconds. Yeah, and the metric is 10. Here we don't have any other bandwidth calculations here. The same time I need to check the adjacency in my R1 router. Here it came, this R1 router, R1 to R2. I have a connectivity. See here, L1 and hold down time is 30 seconds. Already I told you that is 30 seconds is our dead time. See here, 10, 25, 24, 23, 22 I'm getting. Then I need to configure it. I need to configure my R3 router. Area ID, it's the same area ID I'm going to configure here. System back. So I'm going to access the router. That is 2.2. I'm going to ping. Right now I'm in R1 router 1.1. I need to access the router 2.2. Let me check that whether I can able to access or not. So I can able to access because all the adjacency, everything, it came up. Earlier I'm not able to access these. Let me check our routing table. See here, I have a routing entry for the 2.2. So here it is the loopback IP 8.0 I have 9.0, and then 2.0 networks I have. So it is going via 1.2, all the informations I have. So I have a routing table entry. The same thing I need to check here. Table. So the same way I need to check here. I have an entry for the 1.0. It's going via 2.1. So the reverse traffic and forward traffic, both routing informations I have. So I can able to ping 1.1 I can able to ping. Meanwhile, I am going to check this 8.1 IP. I can able to access it right now. Yep, I can able to access that from my R3 router. I'm going to check ping 192.168.9.1. So right now I'm in R1, so I'm going to access this loopback IP 9.1. I can able to access because I configured the IGP protocol, that is ISIS, as per our lab. In this lab, so thank you so much, my dear friends, for watching my videos and supporting my channel. Until I come back with my next awesome video, it's bye bye from Maru. Thanks, have a great day.